All right, today we're going to get into something, well, something pretty wild. I'm talking about what happens when the absolute gold standard of astronomical math, we're talking the exact math that lands rovers on Mars, seems to completely turn our science textbooks on their head.
So let me just ask you this straight up. What would you do if NASA's own math, the math they use for everything, started spitting out data that seems to disprove everything we think we know about the sky? It's a huge question, right? Okay, let's get into it.
Okay, so the main player in all of this is a piece of software called Stellarium. And let's be super clear right from the start. This is not some kind of video game or cool-looking app. No, this is a serious, data-driven tool, a high-precision simulation used by pros, and its credentials, well, that's the whole point of this discussion.
So why do we call it the gold standard? Well, for starters, NASA's Jet Propulsion Laboratory, JPL, uses it for their own education programs. It runs on something called the JPL DE 430 and 431 ephemerides. Now that's a mouthful, but just think of it as NASA's ultra-precise cosmic GPS. And get this, it's the exact same math they use to land rovers on Mars. We're also talking accredited physics degrees at universities, archaeoastronomers using it to literally reconstruct ancient skies. Even the European Space Agency gives it their stamp of approval. So yeah, this isn't some back-of-the-napkin stuff. This is the real deal.
Okay, so now that we've established that the tool we're using is absolutely top tier, let's talk about the two big scientific theories that are about to go on trial.
All right, first up, axial precession. You know how when you spin a top, it doesn't just stay perfectly straight? It kind of wobbles in a slow circle? Well, the mainstream model says the Earth does the exact same thing, just, over a massive 26,000-year cycle. And because of that wobble, where we see a star in the sky tonight should be totally different from where our ancestors saw it thousands of years ago. And this isn't just a vague idea. There's a hard rule for it. The science says our planet's axis wobbles at a rate of 1 degree every 72 years. So burn that number into your brain. 1 degree every 72 years. That's the benchmark. That's the rule we're about to test.
Okay, theory number 2 is called proper motion. The idea here is that every star you see is hurtling through space on its own path, at its own speed, kind of like a flock of birds that just scatters. So if you fast forward a few thousand years, our constellations, the Big Dipper, Orion, they shouldn't look the same at all. They should be completely warped, totally distorted.
Okay, the stage is set. We've got our trusted tool, and we've got our two theories. Let's put them to the test. We're starting at one of the most famous places on Earth, the Great Pyramid of Giza, at exactly 29.98 degrees north latitude. The source material calls this the Giza Zenith Lock. Let's see why.
And this is where things get really, really weird. Look at this data. We've got 4 different stars from 4 totally different constellations spread out over more than 5,000 years of history. And according to Stellarium, using that NASA math, every single one of them hits a declination that's like latitude for the sky that perfectly matches Giza's latitude on Earth. What does that mean? It means the software calculates that they all passed perfectly overhead, straight up, at different times.
And when I say perfectly overhead, I mean perfectly. We're talking an altitude calculated within thousandths of a degree of a perfect 90-degree angle. This is not kinda close, it's what the source calls a hyper-precision bullseye. And it just keeps happening, over and over again.
So, do you see the problem here? This creates a massive mathematical conflict. Remember the precession rule? 1 degree every 72 years? Well, by that rule, a star that was directly overhead at Giza 4,000 years ago should be about 55 degrees away from that spot today. That's more than halfway down to the horizon. But the JPL math in Stellarium says, no, dozens of stars just keep locking onto that exact zenith point for thousands and thousands of years.
Now you might be thinking, okay, maybe that's just some weird glitch for Giza, right? A fluke. Well, the source material thought of that too. So they took this investigation global, and what they found, they're calling it a worldwide mathematical grid.
Let's jump over to another huge ancient site, Teotihuacan in Mexico. It's at 19.69 degrees north. And what do we find? You guessed it, the exact same pattern. Different stars, separated by thousands of years, all locking on to the precise declination of that spot, hitting that same unbelievable hyper-precise zenith.
The conflict here is even crazier. Over the 15,000-year time span they looked at, that precession roll says the sky should have shifted by a whopping 200 degrees. I mean, the sky should have basically flipped upside down. But again, the JPL math just says, nope, these stars keep coming back to the exact same spot, time after time after time.
And it's not just those two places. The source documents this same zenith lock thing happening all over the globe. The Great Ziggurat of Ur in Mesopotamia, Chichen Itza, the Great Pyramid of Cholula in Mexico. It's like everywhere they point the software, this impossible pattern just shows up.
So this quote from the source material really sums it all up perfectly. The constellations aren't breaking apart like proper motion says they should, and the sky isn't wobbling away like precession says it should. Instead, NASA's math shows these star patterns staying perfectly intact and returning to the exact same spots, locking in over these ancient monuments.
All of this data, it all leads to what the source calls the logical checkmate. It's this inescapable conclusion you're forced into when you just follow the numbers from NASA's own math.
So, after all that, what's the verdict? What are we supposed to make of all this? Where does this huge mathematical paradox leave us? The way the source frames it, you're caught in a logical trap. You're left with only two choices, and neither one is comfortable. Choice number one, you accept the stellarium data. If you do that, you have to admit that our bedrock theories of precession and proper motion are just wrong. Okay, what's choice number two? You deny the stellarium data. But if you do that, you're saying that the exact same NASA JPL math that we use to land billion-dollar rovers on Mars is busted. See the problem?
The whole argument hinges on this insane level of precision. Finding a perfect 90.00000 degree result, a perfect integer, is something the source argues is mathematically impossible if the sky is based on all these wobbles and random motions. It's that hyper-precision generated by NASA's own math that springs the trap.
And this quote really says it all, doesn't it? You can't trust the math to land a rover on another planet, but then turn around and say it's just a glitch when it shows something strange over a pyramid? As the source says, mainstream science simply cannot have it both ways.
So we're going to leave you with this to think about. The raw data, crunched by literally the best astronomical math available to the public, seems to be showing us an unmoving, hyper-precise geometric grid. A grid that connects specific stars to specific places on Earth, over and over again. So the final question is, if our best math is revealing that, what does it really say about the sky above our heads?